And there's a bunch of pictures that I want to show you. We'll look at them when we're together, but I'm going to show you a few of them right now. And so here we have solar flares and prominences. These are arcades of magnetic loops containing hot gas that rise above the sun's surface. Those are bigger than the Earth. Here we have magnetic chaos on the sun. We have the aurora. I'm getting a bunch of flash from my camera. This is a very detailed image of the sun's surface. As is this, that's a sunspot right there. This is the sun taken with, it's an image recognizing different light and filtering out certain lights. Prominences erupting from the sun. Here you have a magnetic loop and so forth. And there's more to take a look at, this green image. And I hope that the noise from a child who's crying in the back of the room is not too distracting. But here we go. I'm going to go outside to do this reading, I think, because I think it'll work better. So let's do that. It is apparently today is a very loud day at Starbucks. So here we are, Quebec. As Birkeland predicted, the particles from the sun that penetrate the Earth's magnetic defenses form great electrical circuits that circulate in space like a 15,000-kilometer wide river, acting like a generator with the current flowing down onto the Earth. It streams downwards from the magnetosphere around the so-called auroral oval that rings the poles and back up into the magnetosphere. Electrons and protons travel in clouds, producing sheets of light when they strike atmospheric atoms. Greenish blue due to oxygen, red due to nitrogen. These invisible stratospheric rivers of electricity, 1,000,000 amps of current, can alter the Earth's own magnetic fields temporarily and produce magnetic storms where 1,000,000 megawatts of power are unleashed. That's a lot of power. Mega means million. So that's 1,000,000,000 watts or 1,000,000,000,000 watts of power. In the 19th century, English physicist Michael Faraday discovered that if you take a magnet and move it near a loop of wire, electrical current flows in the wire. We should read about Daniel Faraday. I have a book about him. Michael Faraday. Daniel Faraday is also interesting. I have a book about him too. At any rate, Faraday's magnetic induction was soon put to use in the first electric generator. In fact, magnetic induction is the foundation of electric motors. This induction, this is the effect that occurs on a grand scale as the changing magnetic fields around the Earth in turn induces currents in the Earth's crust as well as in good electrical conductors, such as railway tracks, pipelines, transoceanic cables, and power lines. So you might imagine some higgledy-piggledy could ensue. Currents induced in the Trans-Alaska and other pipelines can produce corrosion that limits their lifetimes. On the 4th of June, 1989, a gas pipeline explosion demolished part of the Trans-Siberian Railway, engulfing 2 passenger trains in flames and killing 500 people. It is thought that magnetic storm damage may have contributed to the accident. Unlike the Siberian pipeline, the Alaskan oil pipeline, built during the mid-1970s, is of a newer technology specifically designed to minimize corrosive currents, now well known to modern pipeline engineers. These currents were also a problem for the telegraph operators of the Wild West. Following the invention of telegraphy in 1841 and the telephone in the 1870s, vast systems of telephone and telegraph lines were strung up across many continents. During solar storms, the currents induced by the Earth's changing magnetic field were so powerful that telegraphers didn't need a battery to send their messages down the line. Some were almost electrocuted. In the Atlantic cable between Scotland and Newfoundland, voltages up to 2,600 volts were recorded during the March 1940 magnetic storm. The storm caused disruption of electrical services in New England, New York, Pennsylvania, Minnesota, Quebec, and Ontario. Notice this chapter is called Quebec, which is in Canada, in a French-speaking part of Canada called Montreal. Well, actually, I'm sorry, Montreal is in a French-speaking part of Canada called Quebec. Quebec is like a state. They call it a province in Canada. Power transmission lines offer a tempting target for the sun because they are connected to the ground by the neutral wires of transformers, therefore offering a path of least resistance. The strong current induced by magnetic storm flows through transformers that were not designed to handle this type of current, causing voltage fluctuations and dropouts. It is a problem that has affected all power utilities located at high latitudes, that is, north and south parts of the Earth. On the 9th of March, 1989, astronomers at the Kitt Peak Solar Observatory in Arizona spotted a major solar flare in progress. The Earth's outer atmosphere was struck by a blast of powerful ultraviolet and X-ray radiation. The next day, an even more powerful eruption launched a cloud of gas 35 times the size of the Earth from active region 5395. The storm cloud rushed out from the sun at nearly 2 million kilometers per hour, and on the evening of 13th of March, it reached Earth. Observers in Scandinavia and Alaska were treated to a spectacular aurora seen as far south as Florida, Cuba, and Mexico. Some who had never seen such a thing before were worried that a nuclear strike might be in progress. Some worried about the fate of the Space Shuttle Discovery, which had just been launched. The cloud of plasma from the sun plowed into the Earth's magnetic field and caused a powerful jet stream of electric current to flow 100 kilometers above the ground. It coiled, gyrated, and stretched deep into North America. Invisible electromagnetic forces were doing battle in the glowing sky and in the subterranean reaches of the Earth itself as powerful electrical currents in the ground surged through the US, UK, Scandinavia, and Canada. Quebec sits on an immense geological shield that prevents current from flowing easily in the ground, forcing the current to seek an outlet. Power lines. In addition, Hydro-Quebec's power grid has very long transmission lines, which increase the currents that can be induced in them. At 2:44:17 a.m., so 2 a.m., 44 minutes and 17 seconds after 2 a.m., those currents found a weak spot in the Quebec power grid. Static volt-ampere reactive capacitor number 12 at the Chibougamau substation. That's Chibougamaau Chibougamau substation tripped and went offline. The loss of voltage regulation at the Chibougamau created power surges and power swings and a reduction of power generation in the 735,000 volt Lagrange transmission network. 2 seconds later, a second capacitor failed at Chibougamau. Then, 150 kilometers away, capacitors tripped at the Albanel and Nemiscal stations, followed swiftly by the La Vendrée complex to the south of Chibougamau. In less than a minute, Quebec lost half its electrical power generation system. Automatic load reduction systems tried to restore a balance between loads, but it was an unequal struggle. One by one, towns and regions across Quebec went dark as the entire power grid collapsed. In Toronto, the nighttime temperature was negative 6.8 degrees centigrade or Celsius. That is, let's see, that is about 22 degrees Fahrenheit. So very cold. Millions were affected. Montreal's underground walkways were plunged into complete darkness. The metro shut down, as did Dorval Airport. Traffic lights failed. It lasted 9 hours, and the total estimated cost was $3 to $6 billion. But it was not just Canada that was affected. This is March 9th, 1989. I was in college in California when this happened. The New York power authorities lost power the moment Hydro-Quebec went down, as did the New England power pool. However, by 9 a.m., New York Power and New England Power Pool were sending over 1,100 megawatts of power to Quebec to tide it over while the system was being brought back up again. Luckily, these states had the power to spare at the time, but only just. In fact, the electrical power pools serving the entire northeastern United States came very close to going down. Some 1,500 kilometers away, Allegheny Power, which serves Maryland, Virginia, and Pennsylvania, lost 10 of its 24 capacitors. Capacitors are electrical storage structures or systems. They're like large batteries. Sometimes what they are is big spinning things. They get spun really fast by electrical power when they have excess electrical power, and because they have a lot of momentum, they keep spinning and spinning and spinning, and when you need power, you hook up a generator to these spinning things, and it then releases some its spinning energy as electrical power by powering a generator. At any rate, they lost 10 of its 24 capacitors. Across the United States, over 200 transformers and relay problems occurred within minutes of the start of the storm. Around 50 million people in the United States went about their business or slept, never suspecting that their electrical systems had been driven to the edge of disaster. All that prevented them from joining their Canadian friends in the dark were a dozen or so heroic capacitors on the Allegheny Power Network. Automatic garage doors in California's suburbs began to open and close without apparent reason as offshore Navy vessels switched to low-frequency backup transmitters. Microchip production in the northeastern United States came to a halt several times because the ionosphere's magnetic activity resulted in poor-quality wafers. In orbit, communication satellites that used the Earth's magnetic field to point themselves tried to flip themselves upside down. A few satellites in polar orbit tumbled out of control for several hours. Weather satellite communications were interrupted, causing weather images used for daily forecasts to be lost. NASA's TDRSS-1 communication satellite recorded over 250 electrical and communication incidents. In low Earth orbit, the Space Shuttle Discovery was having its own problems. The hydrogen is exhibiting a pressure signature that we haven't ever seen before, said the flight director, Granville Pennington, at the Johnson Space Center. Space storms didn't even have to take a direct swipe to harm a satellite. Atmospheric friction causes other headaches. During the Quebec blackout, the U.S. Space Command had to recompute orbits for more than 1,300 objects affected by momentary increases in air resistance after the added energy puffed up the atmosphere like a balloon. In March 1989, Quebec blackout has reached legendary stature among electrical engineers and space scientists as an example of how solar storms can affect us. Fortunately, storms as powerful as this are rare, occurring once every 10 years or so. We have weathered half a dozen solar activity cycles since the end of World War II. But as solar maximums and solar storms come and go, the world has been changing, becoming more reliant on electronics, satellites, and communications. In 1981, at the peak of solar cycle 21, there were 15 communication satellites in orbit. Mobile phones were rare, and there were less than 1 million personal computers sold in the US, and only 300 hosts on the internet. By the time the peak of the next solar cycle came around in 1989, there were 102 communication satellites and 3 million cellular phone users in the United States alone, as well as 300,000 host machines on the internet. The world had changed even more as we passed through the peak of the 23rd sunspot cycle in 2000 to 2001. Now there were 349 communication satellites. Hundreds of millions of people have cellular phones, and global positioning system handsets are routinely used for work and leisure. That's the GPS structure. There are over 10 million internet hosts. More electricity than ever is flowing in the world's power grids. In May 1998, when the Galaxy 4 satellite tumbled out of control for a while, over 90 million pagers in the U.S. were silenced, as well as radio and television feeds and newspaper services. Just one satellite failure did this. The U.S. electric system includes over 6,000 generating units, more than 800,000 kilometers of bulk transmission lines, and approximately 12,000 major substations, all served by 100 separate control centers. All are vulnerable to solar attack. We have learned to cope with energetic storms that occur every 100 to 1,000 years on their We have learned to cope with much of what the sun has thrown at us. But there must be more energetic storms that occur every 100 to 1,000 years on their way that will surprise us. The sound of the aurora I'm going to read about later. So for right now, I'm going to stop. And good night, Devon. Sleep tight. Don't let the chappies bite. I'm sending you some kisses. Mwah. 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 I love you. Sleep well. Sweet dreams.